The letters USGS and word Science for a Changing World appear in white.
Good morning or good afternoon, depending on where you may be. I'd like to welcome you to our webinar that's covering an overview of the USGS 3D Elevation Program and 3D Hydrography Program for tribes. We'll start with a quick agenda and some introductions here, which will follow those introductions with an overview of the 3D Elevation Program and uses for the data. And then my colleague, Sue Budo, will discuss an overview of the 3D Hydrography Program and uses for that data. And Cindy Thatcher will then follow with an explanation of the tribal notification process. At the conclusion of the presentation, we will hold a question and answer session, and we're happy to stay as long as necessary to answer your questions. So my name is Brian Hadley. I am with the U.S. Geological Survey's National Geospatial Program, and I am the Elevation Data Acquisition Lead. I am all located in Denver, Colorado, and I will turn it over now to my colleagues to introduce themselves.
Thank you, Brian. I am Sue Budo. I'm the Hydrography Data Acquisition Lead for the 3D Hydrography Program, and I am in Beaverton, Oregon.
Cindy Thatcher. I work on the 3D Elevation Program team, and I'm located at our USGS headquarters in the Washington, D.C. area.
Thanks, Sue and Cindy. Some webinar logistics for today. I want to point out that this presentation is being recorded, and everyone but the speakers have been placed on mute for the duration of the webinar. So please use the question and answer feature in Microsoft Teams to submit your questions. You see the little red arrow pointing down to where the Q&A window is. We will answer all of your questions at the end of the webinar, and we'll group similar questions so that we can address as many as possible during today's session. The USGS is the science arm of the Department of Interior, bringing our science to bear on a wide range of environmental, resource, and public safety issues. The USGS's mission and vision statements are targeted towards delivering our science to decision makers in the most effective manner that we can. All our mission areas are focused on delivering science that matters, what we call actionable information. In 1884, the USGS was charged with mapping the interior of our great nation to help us understand our lands and resources. Today, we continue to lead this charge in the digital information age, delivering foundational science, data, and Earth remote sensing systems. Investments in USGS science, boosted by President Biden's Investing in America agenda with the enthusiastic support of Secretary Deb Haaland, are absolutely critical to our ability to produce practical, pragmatic, and impactful science to address some of the most challenging issues facing our nation's environment and resources. The USGS Core Science Systems mission area builds on the core strengths of the USGS in characterizing and understanding complex Earth and biological systems through research, modeling, mapping, and the production of high-quality data. Core Science Systems delivers natural science information to the nation in support of smart decision-making. The USGS Core Science Systems mission area spans the Earth's critical zone. The Earth's critical zone is the heterogeneous near-surface environment in which complex interactions involving rock, soil, water, air, and living organisms regulate the natural habitat and determine the availability of life-sustaining resources. USGS Core Science Systems mission area also provides a foundation for all USGS mission areas, as well as the mission of the Department of the Interior in the following ways. It serves as the nation's civilian mapping agency, provides remote sensing, topographic, geologic, and biogeographic data and maps to the nation and the world, coordinates effective and economical use and management of geospatial data assets for federal agencies and the nation, operates the Landsat satellites to collect, archive, process, and deliver science quality data, provides land cover analysis and products using remote sensing imagery from satellites, provides multidisciplinary research and data to understand and anticipate the changing climate, environment, and land use, and finally, inventory and preserve geological and geophysical data collections to provide a framework for geoscience data and information sharing. The 3D National Topography Model, or 3D NTM, is designed to deliver the terrestrial component of the 3D nation vision by integrating national elevation and hydrography datasets to model the nation's topography in 3D. 3D NTM is an initiative that includes three components. The first is the 3D Hydrography Program, or 3DHP. 3DHP is an application of the 3D elevation program that derives hydrography data from LIDAR Alaska IFSAR, ensuring integration of the two datasets for the first time since they were originally surveyed for the USGS topographic map series. Other enhancements include to provide new connections to groundwater, wetlands, and engineered hydrography, and improve water-related sharing, implementing the 3DHP infrastructure as the underpinning of the Internet of Water. The second component is the next generation of the 3D elevation program, or 3DEP, which is being designed with all new quality levels and refresh cycles, and will integrate inland bathymetry with terrestrial elevation data. The 3D ecosystem is envisioned as a federated system of data lakes that will allow sharing of data, tools, code, and other resources. Because we plan to continue to incorporate new technology and approaches over time, we will assess the next Gen 3DEP program design on a regular cycle of 3 to 5 years. This new strategy will allow for continual improvement in the program. Third component is a vision for a future integrated 3D model. We are beginning research and development to more fully integrate 3DHP and the next Gen 3DEP, and to integrate other data from the national map and the 3D data model. The goal of 3DEP is to complete acquisition of nationwide LIDAR, or IFSAR in Alaska, to provide the first ever national baseline of consistent high-resolution topographic elevation data, both bare earth and three-dimensional point clouds. At present, we have approximately 95% of the nation in progress or completed and published. Airborne LIDAR data are collected from aircraft by using sensors that detect the reflections of a pulsed laser beam. These reflections are recorded as millions of individual points, collectively called a point cloud, that represent the 3D positions of objects on the surface of the Earth. Objects can be buildings, vegetation, infrastructure, the ground, etc. LIDAR is transforming mapping by providing highly accurate maps of the Earth's surface and three-dimensional data of all the natural and man-made features that are on the surface. 3DEP products include 3D LIDAR point clouds, bare Earth digital elevation models, or DEMs. 3DEP informs critical decisions that are made across our nation every day that depend on elevation data, ranging from immediate safety of life, property, and environment to long-term planning for infrastructure projects. All of the images on this slide are derived from LIDAR and highlight the diversity of science and business applications for the data. At the USGS, our scientists are using LIDAR data to identify critical mineral deposits, to map ancient lava flows from volcanoes and predict future volcanic hazards, to map landslide occurrences, as well as many other applications. Other federal agencies use LIDAR data to map flood risk, precision forestry, aviation safety, natural resource conservation, agriculture and precision farming, and infrastructure management. Digital elevation models are one of many products that can be derived from LIDAR data, though they can also be derived from other sources as well. Bare Earth DEMs are digital representations of the Earth's topographic surface. They're a, quote, bare Earth product because they don't include surface features like buildings and vegetation. A high-resolution DEM can be derived from LIDAR point cloud data by stripping away the surface features and sampling the ground elevation in uniform increments to produce a bare Earth model. 3DEP LIDAR-derived DEMs are produced at 1 meter spatial resolution. For Alaska, 3DEP DEMs are derived from interferometric synthetic aperture radar, or IFSAR data, at a 5 meter spatial resolution. The three blue-green images at the top of this slide show bare Earth DEMs for the Meridian Regional Airport in Mississippi at 30 meter, 10 meter, and 1 meter spatial resolutions. One can quickly see how the finer spatial resolution 1 meter DEM makes it easier to identify smaller features on the surface, such as the airport runway, roads, and hydrological features. The grayscale images below show bare Earth DEMs of a glacier in Alaska at 60-meter and 5-meter spatial resolutions. Please again note how the finer spatial resolution 5-meter DEM provides a greater level of detail in the mountainous terrain and on the surface of a glacier when compared to the 60-meter DEM. LiDAR data are gathered as a dense collection of points with X, Y, and Z values. The points collectively are referred to as a point cloud. These images on this slide portray different features on the landscape represented by LiDAR point clouds. The image on the left shows a point cloud of the city of Chicago, Illinois. The image on the upper right shows a point cloud of a mesa in the state of New Mexico. The multi-temporal images on the lower right side show LiDAR point clouds of pre-fire and post-fire vegetation near the Cheeseman Reservoir in Colorado. Archaeology is scientific study of material remains such as tools, pottery, jewelry, stone walls, and monuments of past human life and activities. We have included this slide on archaeology because this type of application illustrates why some tribes have privacy concerns about their LiDAR data. In most landscapes, LiDAR laser pulses can penetrate vegetation to reveal details on the ground surface hidden or obscured beneath the vegetation. However, LiDAR does not penetrate below the ground surface itself. Tribes tell us that they are concerned that culturally sensitive features might be visible in the LiDAR data. Because of these concerns, we frequently work with tribes to protect their privacy by not publishing the LiDAR data upon request. Over the past several years, you may have received one or more notification letters offering consultation about 3-depth LiDAR acquisition because our agency has determined that publishing LiDAR data may have an impact on tribes. Therefore, we are required to notify you before we publish the data on the national map. This slide describes some options for addressing tribal privacy concerns. Firstly, we offer tribes the opportunity to review the data before making a decision on data publication. If they choose to protect the data from public access, we can either remove certain tiles or we can remove all of the data for a tribe's lands. Any other funding partners on the project are required to honor the tribe's decision. All that is required is a simple email from the tribal leadership documenting your request. The next couple of slides provide specific examples of how different tribes are using LiDAR data for various natural and cultural resource applications. The Yurok tribe and Kootenai tribe of Idaho are using bathymetric LiDAR data for fish habitat restoration. Similarly, the Nisqually Indian tribe funded a bathymetric LiDAR survey of the Nisqually Delta to support salmon recovery. The Nez Perce tribe is using LiDAR data to assess hazards including post-fire landslides, debris flows, and floods, and to evaluate ecosystem restoration in disturbed areas. The Little Traverse Bay Band of Ottawa Indians are using LiDAR data for the survey and inventory of cultural resources, land use planning, and the identification of wetlands. Other tribal applications of LiDAR data include forestry, transportation, and water resource management. For example, the Fort Belknap Indian community is using LiDAR data for forestry applications, including slope analysis to calculate the percentage of timber resources that can be harvested with different logging techniques, and to better define logging road layouts for forest and timber harvest. Blackfeet Nation, the Fort Belknap Indian community, and the Fort Peck tribes are using LiDAR data to develop multiple transportation route alternatives before public hearings, and to save time and money on tasks required to define the scope of transportation engineering projects. Lastly, the Wind River Indian Reservation is using LiDAR data to analyze storm drainage patterns in the Fort Washakie community. The 3-depth LiDAR Explorer is a web-based map viewer for downloading and viewing USGS 3-depth LiDAR data. LiDAR Explorer allows users to define their area of interest, select and filter products based on needs, create processing pipelines for transforming the data into derived products or results, and execute processing pipelines using cloud computing resources. The link to the LiDAR Explorer application is shown at the top of this slide, but you should be able to find it quickly by searching for LiDAR Explorer in your favorite internet search engine. I will now turn the presentation over to my colleague Sue Butow, who will provide you with an overview of the 3D hydrography program.
Thanks, Brian. So as with elevation data, the USGS has a long history of providing hydrography data to the nation, first through mapping surface water on our topographic maps and later as digital data. So for 25 years, the National Hydrography portfolio of data sets consisting of the National Hydrography Dataset, or NHD, the Watershed Boundary Dataset, or WBD, and the NHD Plus High Resolution have served as the most comprehensive and current data of the nation's surface waters. The NHD includes about 9.4 million miles of stream network, including 8 million water bodies and over 130,000 nested hydrologic units in the WBD. Maintenance for the NHD and the WBD leveraged local knowledge and updates through a stewardship program with participants from 41 states and Washington, D.C. The stewardship program was a great collaborative effort, but updates made to the data have not been uniform over time. So the hydrography mapping may be current in areas where stewards had resources. However, many areas have been left untouched, so the mapping is based on information that can be 40 or more years old. Updates were also based on many different base materials and methodologies. This means that the consistency of the data set at the national scale has decreased over time. And importantly, as more high-quality elevation data are increasingly available, the surface water features in the NHD and watershed boundaries in the WBD don't align well with highly accurate 3D elevation program data. So to address these issues and in response to user needs identified in the Hydrography Requirements and Benefits Study, or HRBS, that we published in 2016, USGS has embarked on an effort to greatly improve the level of detail, consistency, and spatial accuracy of the nation's surface water mapping and bring it into alignment with the baseline 3DEP elevation data. The 3D Hydrography Program, or 3DHP, will not just improve alignment with the 3DEP elevation data, it will also modernize the approach to mapping, delivering, and maintaining these critical data sets. The 3DHP will build on decades of work that went into the NHD and the WBD, but represents a fundamental transformation in how national hydrography data will be acquired and maintained. The program is moving toward a set of best practices based on the 3DEP best practices. And these include leveraging the expertise and capacity of private sector mapping firms that will acquire data for the 3DHP through the USGS Geospatial Products and Services Contracts, or GPSC, and through acquisition contracts that are managed directly by partners. And more consistent data governance practices also will be employed. And a key goal of this transformation is to ensure that uniform, high-quality data exists for all data users, regardless of their location. Data that are accurate, precise, and consistent are possible because of standards and specifications. So we've developed the first formal published specifications for hydrography mapping since the standards for the old topographic maps were developed. Data will be tested to make sure that it meets the specifications before being included in 3DHP. And as noted earlier, this is a big shift from our previous approach to data update and maintenance, which relied on stewards and local knowledge. This slide shows what we're aiming for. On it, we have older NHD data mapped in pink or magenta and updated elevation line data for the 3DHP shown in blue. Building a more nationally consistent data set that's aligned with elevation data will support local needs and reduce effort required to use the data for numerous applications. This effort includes significantly simplifying the GIS data model and will focus on support for hydrologic applications, in addition to being used for cartography. The 3DHP will also, over time, reduce duplication of effort by tapping into rather than remapping authoritative data sources. And this includes connections to and improved interoperability with the U.S. Fish and Wildlife Service National Wetlands Inventory. 3DHP also will support the Internet of Water, which aims to provide an information infrastructure for federated sharing and discovery of water information in the context of the geospatial stream network. Simply said, this functionality is similar to web searches that provide us information in context with location. So for instance, if I use Google to find coffee shops near me, I get a listing of all searchable coffee shops and not a single brand or outlet. Similarly, water observations for any agency that has linked data to the stream network in 3DHP and made it searchable will be included in a search, which saves hours of time looking through various disconnected resources for information of interest. So in this way, 3DHP and the Internet of Water is a big step towards making water observations and water information fair or findable, accessible, interoperable, and reusable, as well as consistent and of high quality. The applications for digital hydrography data shown on this slide are not comprehensive, but are meant to highlight the diversity of science and business applications for the data. The data can be used to map and maintain riparian buffers, locate and mitigate barriers to fish passage, and monitor the health of aquatic habitat. And they support flood modeling and response, as well as spill response and water quality modeling and monitoring, among many other myriad applications. So the National Tribal Notification Letter that was sent in early February was the first sent for this new program. And we'll have a little more detail about the notification later in this presentation. I'll just note that where there are tribal LiDAR restrictions in the 3D elevation program data, USGS currently plans to use alternate data sources to generate 3DHP to honor those tribal restrictions. So this is a year of transition from the legacy hydrography data and the NHD and WBD to 3DHP. We're creating and posting static versions of the NHD and WBD that will be available for the foreseeable future from the national map or from direct download. Direct downloads can be accessed from usgs.gov/NHD/data access. 3DHP data will initially be available as a service layer, followed by downloadable data. And the 3DHP will contain NHD geometry until a watershed is updated with new elevation aligned data. And the older NHD geometry in the 3DHP data model will have limited functionality, but will provide network connectivity until the new data is collected and ingested into the new data set. So finally, a note about partnerships in both 3DEP and 3DHP. Both are partnership programs. And the USGS acts as the lead program manager to facilitate planning and acquisition for the broader community through government contracts and partnership agreements. And our annual data collaboration announcement, or DCA, is the mechanism for non-federal entities to partner with USGS to fund data acquisition. Some of you may know this process in its previous form as a broad agency announcement, or BAA. Your national map liaisons or the data acquisition leads, myself and Brian Hadley, are happy to discuss the DCA with you at any time. And for more information, you can visit the DCA portal that can be accessed from usgs.gov/3dntm/DCA. And now I'll pass it to Cindy Thatcher for more information about the tribal notification process.
Okay, thank you, Sue. So a national notification about the new 3D hydrography program and a new generation of the 3D elevation program was recently sent to give tribes the opportunity to ask questions or consult with USGS about these new national programs, and to ask questions or consult about the national data acquisition plans for these programs. And we want to note that you can always contact USGS at any time to discuss these programs and ask any questions about data produced for your lands. For 3DHP or 3D hydrography program, we will not be sending additional notification letters for individual 3DHP projects. We'll just be sending a general national notification letter similar to the one you just received about every 2 years about 3DEP and 3DHP. For 3DEP, we will continue to send customized notification letters for individual 3DEP projects, and those letters will be sent before the data is published. And the letters will look very similar to the ones that we've been sending to tribes for the past several years. So this is an image of what the letter looks like, the project-based letter. So this is a custom letter with a map of the 3DEP LiDAR acquisition project area. It includes a list of any funding partners on the project, description of how the data will be published, and then also some general information about the 3D elevation program. And we send these letters to the tribal chairperson, the Tribal Department of Natural Resources, and the Tribal Historic Preservation Officer if the tribe has one. The goal here is to provide tribes the information they need to understand the USGS LiDAR mapping projects, and then to give tribes the opportunity to work with us to address any concerns that they may have about the data. After we send the letter, we wait 45 days for a response before we proceed with data publication. So here's a map of our National Map Liaison Network. These National Map Liaisons handle a lot of the follow-up communications with tribes and serve as your main point of contact. And these people are a good resource for talking about any questions you may have about hydrography or elevation data, or how to access the data through the national map, or if you want to learn about other aspects of the national map, such as US Topo. Their contact information is available at the website there on the bottom right of the slide. You can also search USGS National Map Liaisons. Anyway, this website, if you scroll down, it will provide their contact information. So with that, we're going to end the presentation part of the program today. First, I want to thank you very much for your time and for attending this webinar. I wanted to point out that you can also reach us at this email here in the center of the screen, 3deptribal@usgs.gov. We'd be happy to hear from you.
The letters USGS in Word, Signs for a Changing World appear in white.